let's learn about electronegativity today. So, electronegativity can be defined as the ability of an atom to attract electron to itself when it is involved in a chemical bond with another atom. Consider this as a game of tug of war between two atoms involved in bonding, where both the atoms are trying to pull the shared electron to their side. Let's look at it with an example of water molecule. Water has one oxygen and two hydrogen that are involved in a chemical bond. Oxygen has an electronic configuration of 2s2 2p4. That means it has 6 electrons in its outer shell, and it needs 2 more electrons to complete the octet and attain stability. So oxygen is desperately in love with electron. So what will oxygen do? Oxygen will start pulling the electrons of hydrogen atom closer towards it, making a partial negative charge on the oxygen atom and partial positive charges on the hydrogen atom, making it a polar molecule. So here the oxygen is the more electronegative atom. So oxygen has pulled the electrons away from the hydrogen towards itself, imparting a negative charge or a partial negative charge on itself. Now let's see how the electronegativity trends across the periodic table. So when you move from left to right, the electronegativity increases. This is because there is an increase in nuclear charge as you move from left to right. So the stronger the positive charge, more will be the bonding towards the electrons. And also, as you move from left to right, electrons are added to the same energy level, causing the atomic size to shrink due to the strong nuclear attraction. So smaller atoms will hold on to their shared electrons more tightly. And also, elements on the right side like fluorine and oxygen are close to completing their octet. So they'll have a stronger tendency to attract electrons to achieve stability. And if we move from top to bottom across a group, the electronegativity decreases. Why? Because as we go down the group, more energy shells are added. This will cause the outermost electrons to be further away from the nucleus, reducing the attraction. Also, inner electrons will shield the outmost electrons from the nuclear pull, which weakens the attraction for the bonding electrons. There are some exceptions. Noble gases, since they have a complete octet value, they do not have electronegativity values. And also transition metals, the electronegativity values do not follow the trend due to the involvement of d orbital. Now, if you look at the periodic table, fluorine is the most electronegative element in the periodic table, and the least electronegative element are cesium and francium. Also, generally metals have a low electronegativity value, so they have more tendency to give away their electrons. So, to conclude, consider electronegativity as a tug of war between two atoms when they are involved in a chemical bond. Whoever has more electronegativity will attract the electrons to their side. Hope you have learned something new. Thank you.